Chapter 6. How much does temperature matter in pipeline simulation? Water is a pretty amazing fluid in that its physical properties, density and viscosity, are pretty much unaffected by temperature. It is unique among fluids we move through pipelines in this way. Pretty much all of the other gases we move have densities strongly affected by temperature, and liquids have viscosities strongly affected by temperature. So we do need to get the temperature in the pipeline right for the pipeline simulation to be accurate. There are two main sources of temperature changes in a pipeline. If we first consider a perfectly insulated pipeline, even then we're going to see the temperature of the fluid changing as it moves down the line. This is because friction in the pipe converts energy from compression energy in the fluid to heat, so heats the fluid, and also for gases, the changing density moves heat in and out of intermolecular forces. And so a natural gas pipeline actually sees the gas getting colder as it moves down the line. A liquid pipeline typically sees the liquid getting warmer as it moves down the line. And that's just for a perfectly insulated line. For an exposed above ground line, the temperature of the fluid is very strongly affected by things like whether there happens to be a cloud in front of the sun right now, as the sun heats the line, or how much wind there is. But most of the pipelines we model are buried, and so this provides some amount of buffering. However, it also gives some additional complexity because to get a very accurate pipeline model, it's necessary to model the heat flow in the pipeline's surroundings. You can read about all of this in Chapter 6 of the Atmos Book of Pipeline Simulation.